All right, welcome back, you guys. In section 7.2, we're going to get into these inverse trig functions continuous. So we're going to get into the arc secant, arc cosecant, and arc cotangent. In other words, the inverse of the secant, inverse of the cosecant, and so on. And so how I like to remember about this, and we won't get in too much into the graphs of this, but I'll give you a brief overview. If you remember, the secant had vertical asymptotes as negative pi halves to pi halves. And it went up, it was almost like a quadratic, but from 0, 1. And then at pi, it was at negative 1, 3 pi halves. Anyways, and it repeated this. Well, I can't cut this off between negative pi halves and pi halves because it's not 1 to 1 again. And so what they did with the secant function is they cut this off between 0 and pi. Okay, so the rest of this part is not there. Okay, so now can you see how this is now 1 to 1, only hit one time? Okay, and so it's cut off between 0 and pi. The arc cosecant, if you think about the arc cosecant, that one's cut off between negative pi halves and pi halves. And then they took the cotangent and they cut that one off between 0 and pi. And that's what you want to keep in mind as you're doing these ones. Okay, so let's do some problems, similar algebraic problems, similar to last time, except with the arc, with the inverses of the reciprocal functions. So we'll start out here and we'll take the arc secant of 2, we'll set it equal to theta. And then we'll say, well, if the arc secant of 2 equals theta, that means the secant of theta equals 2. And, the secant, of course, the reciprocal, the cosine. But similar to the cosine, it is also cut off between 0 and pi on this. So that's what you want to keep in mind, is the secant of theta is 2, which means 1 over the cosine is 2. We'll solve for cosine now. Let's see if I can move this over. Sorry guys, I'm trying to move that. We got 1 over cosine. Let's go ahead and solve that. Let's get our cosine on the top. So 1 equals 2 cosine. Let's go ahead and get rid of the 2 here. So it looks like we got cosine of theta is a half. Remember, we're looking just between 0 and pi. So now I'm looking on my unit circle, somewhere between 0 and pi. Where do I have a cosine that's a half? Right, so I'm like, where do I have a cosine that's a half? What angle is that? And hopefully you recognize that as that theta would be pi thirds. At 60 degrees, I have a cosine that's a half. Cosine of pi thirds is a half. Therefore, the arc secant of 2 equals theta, and we determine theta must be pi thirds. Next one here, we've got the arc cosecant, or the inverse of the cosecant. So cosecant negative root 2, so I'm going to set it equal to theta. That means the cosecant of theta is negative root 2, and I've cut off the cosecant between negative pi halves and pi halves, so I know my theta is between there. Negative pi halves and pi halves. Okay. And so now I say, well, that's 1 over sine is negative root 2. I'm going to multiply both sides by sine, so I have 1 equals negative root 2 sine of theta. I divide both sides by negative root 2 now. Let me come over here. So I have sine of theta is 1 over negative root 2. Let me take the negative up top, and then we'll go ahead and we'll rationalize that. So root 2. So I have sine of theta is negative root 2 over 2. Okay. And so now I'm looking, remember, we're looking between negative pi halves and pi halves. So I'm looking on my unit circle between negative pi halves and pi halves. I say, okay, sine of what? Well, if the sine value is negative, or in other words, the y is negative, right? Which one has a sine that's negative root 2 over 2? You find that, and you say, oh, that's, well, it's not 7 pi fourths because it's got to be that negative angle, right? So it's not 315 degrees, it's the negative of that. So that would be negative pi fourths, or negative 45 degrees. So theta must be the negative pi fourths. Negative pi fourths. And now that we know the theta, we go back here, erase this, give myself a little bit of room. Then I'll say, well, if theta's negative pi fourths, remember we called the arc cosecant, therefore, the arc cosecant of negative root 2, which we called theta, is negative pi fourths. We know theta is negative pi fourths. All right, with the arc cotangent, so this would be, go ahead, set it equal theta. That means the cotangent of theta would be negative root 3, and we know theta's got to be between pi and 0, okay, because that's where we had to cut off the cotangent in order to create the arc, or the inverse cotangent. And so then we're saying to ourselves, well, cotangent's cosine over sine. And it's negative root 3. And so I'm looking on my unit circle. Pull up unit circle here. And we're looking between 0 and pi, right? In quadrants 1 and quadrant 2, where the cosine over the sine is negative root 3. So let's say we tried like pi 6. Is root 3 over 2 over 1/2? Right, we're trying to get, where does the cotangent equal negative root 3? In other words, the cosine over the sine. This is what we were asking, is negative root 3. Well, if it was pi 6, if we were going to try pi 6, root 3 over 2 over 1/2, if you simplified that, you just have positive root 3. Again, we need negative root 3. So we're like, well, that's not going to work. This one's not going to work because cosine over sine there gives you 1. 1/2 over root 3 over 2 gives you 1 over root 3. So it's got to be this over here at 5 pi 6. Negative root 3 over 2 over 1/2, that cleans up to just negative root 3. So it's got to be 5 pi 6. Again, we're looking between 0 and pi, and that's where the cosine over sine is negative root 3. All right, so let's put it on here. So we've determined it's got to be at 5 pi 6 because that has a cosine that's negative root 3 over 2 and a sine of positive 1/2, which gives you negative root 3. So we know theta's got to be 5 pi 6, 150 degrees. That's where it occurs. Therefore, the arc cotangent of negative root 3 equals theta, which we determined must be 5 pi 6. Okay. All right, now what we're going to do is we're going to take a sine on an arc cosine. Now this arc cosine of 3/5, we're going to have to draw this. These involve drawing a triangle, labeling the sides. Excuse me, this is not on the unit circle. Okay, this arc cosine of 3/5. And so what I'm going to do is I'm going to start first, number 1. Let me start with this arc cosine of 3/5. And let's go ahead and set that equal to theta. And let's make this statement then that the cosine of theta must be 3/5. Now remember, we cut off the cosine between 0 and pi. And so when I draw this, I have a positive cosine. Cosine is positive, so it's a positive x, right? So I know I've got to be, even though it could be in quadrant 1 or quadrant 2, if the cosine is positive, I know it's got to be in quadrant 1. So I'm going to draw this triangle into quadrant 1. This is the adjacent. That's your hypotenuse. Here's your theta. So I say, okay, there's my adjacent side, the leg right next to the theta. There's my hypotenuse opposite the 90. And let's go ahead and solve for the other side. So I know a squared plus b squared equals c squared, right? So my a is 3, b I don't know, c is 5, so I got 9 plus b squared equals 25. I subtract 9, subtract 9. So b squared ends up being 16. So b is plus or minus 4. And this is a side length, so we're going to say, well, that's 4, positive 4, right? And you want to double check it. Positive 3, positive 4. Right? Cosine's positive, and so the sine is also positive in the first quadrant. All right. So now we got the triangle written. So that's step 2 is to draw your triangle. Step 3 is to come back to this problem. We have the sine of the arc cosine of 3/5. Now, notice I called the arc cosine, I called it theta. So really what I'm finding is the sine of theta, and I have theta set up. Remember, sine of theta, so I can use right triangle trig to do this. Sine of theta is opposite over hypotenuse with right triangle trig, right? So the opposite side is a 4. 4, hypotenuse is 5. Therefore, the sine of the arc cosine of 3/5 is 4 over 5. All right, so this time, now we got a cosine of an arc sine. Cosine of an arc sine. So again, we'll do the inside first. So number 1, let's go to the side and figure out if we can draw this. The arc sine of -1 over root 6. So I'm going to go ahead and set it equal to theta. That means the sine of theta is -1 over root 6. And remember, we cut off our sine between pi halves and negative pi halves. Okay? So if our sine is negative, right? And I can only be in one of these quadrants, quadrant 1 or quadrant 4. But if my sine is negative, then you're thinking, well, I've got to be in quadrant 4, right? Sine of theta is negative. I got to draw theta into quadrant 4. So y value is negative there, if you will, right? But again, this is not on the unit circle, but I got to draw this properly so I can set this up. So let's go ahead and draw it. Here's theta into quadrant 4, and we draw the triangle. I go straight back to the x-axis, and I'm actually using the reference angle theta prime in here when I do this. Okay, because right triangle trig is only for acute angles. I know theta is larger than that, so it's kind of our Jimmy rig way to be able to do these problems. Now, sine is opposite over hypotenuse. So here's my opposite side. Here's my hypotenuse side. So the opposite side, using theta prime, opposite side's -1. Hypotenuse is root 6. Okay, so I need to solve for this a value, I'll call it. So this is a positive a. Notice I have a negative y, -1, right? And that's just so that I label that. I know it's a distance, but I label that as negative because we're in quadrant 4, so the sine value is negative. If I don't label that as a negative, the problem won't work out for us from the givens, right? All right, let's go ahead and solve for the side length. So we got a squared plus b squared equals c squared. So I've got a squared plus 1 equals 6. I subtract 1. A squared equals 5. Square root. A equals plus or minus root 5. So go over here and I say, well, this is positive. It's a positive x, right? And a negative y. So positive root 5 there. And finally, step 3, let's put this all together. Cosine of the arc sine, -1 over root 6. Remember, we called the arc sine of -1 over root 6. We called that theta over here, right? We called it theta. So we're just finding the cosine of theta using theta prime, the reference angle in red. Well, cosine, right triangle trig, is adjacent over hypotenuse. So I'm going to use my theta prime. I'm going to go the adjacent side over hypotenuse. Adjacent side over the hypotenuse. And don't forget, we do need to rationalize that. Notice I got a new color. I'm excited about my orange. So there's our cosine of the arc sine of -1 over root 6. It's root 30 over 6. Let's go ahead and do that inside right there. We've got number 1, let's call the arc cosine of -3/4. Let's call it theta. That means the cosine of theta would be -3/4. And when we cut off the cosine, we cut that off between 0 and pi. So when I draw this, I'm either going into quadrant 1 or 2. Well, if the cosine's negative, right, the x value, if you will, then I got to be in quadrant 2. So I need to draw this thing into, when I draw this, I need to draw this into quadrant 2. And then I drop that straight down. Here's my theta. We're using right triangle trig for an angle larger than 90, so I got to use theta prime to kind of make this work, to force its hand. We know the cosine's adjacent over hypotenuse. So using theta prime, the adjacent side's right there. The hypotenuse is 4. And notice, -x, +y. So when I find this b value, make sure it's positive, right? Let's go ahead and solve for b. I got a squared plus b squared equals c squared. So b squared equals 7. So b equals ± root 7. So we'll fill that in with root 7. And now we got it all set up, so we can do step 3. Tangent the arc cosine -3/4. Remember, we called that theta. So we're finding the tangent of theta. Well, tangent's opposite over adjacent. And so I look over at theta prime and I say, well, the opposite side's root 7. The adjacent side's -3. So root 7 over -3. That'd be the tangent of theta. Go ahead and take the negative up top. And we know theta is that arc cosine, right? So we know the tangent of the arc cosine, -3/4, is -root 7 over 3. And let's move on. Number 1, take that inside. Set equal to theta. That means the tangent of theta would be -1/3. Remember, we cut off with the tangent, we cut that off between -pi/2 and pi/2. And so number 2, let's go ahead and draw that. If the tangent's negative, and it could be in between -pi/2 and pi/2, so sine over cosine is negative. It's not going to be quadrant 1 because that'd be a positive sine over a positive cosine. It'd be a positive value for tangent. So it's got to be in quadrant 4. I'm going to draw this in quadrant 4 because the sine's negative there. The y value is negative. And the cosine's positive, right? I get positive x, -y. So let's draw this into that quadrant. And so That's our theta. We're using theta prime though here, and our theta prime is between negative pi halves and pi halves, so it actually is rotating negative, just like the red theta prime there. And our tangent's opposite over adjacent. So opposite adjacent. Again, double check your values. Positive x, negative y. So that's okay. Let's go ahead and solve for the hypotenuse. 3 squared plus negative 1 squared equals c squared. So 9 plus 1 equals c squared. So c equals square root of 10. There it is. There's our square root of 10. Hypotenuse always positive there. And step 3. Cosecant, remember we called the arctangent, we called that theta, equals. Well, cosecant's a reciprocal to sine, right? We know sine is opposite over hypotenuse, so this will just be hypotenuse over opposite. Well, the hypotenuse is root 10, opposite is negative 1. So root 10 over negative 1, or negative root 10, take that up to the top. So the cosecant of the arctangent of negative 1/3 is negative root 10. All right, now we're going to keep it in terms of u this time. So let's start with the inside. So the arc, if the arc sine of u, if we let that be theta, then we know sine of theta is u. And remember, we cut off theta. Theta is between negative pi halves and pi halves, right? That's where we cut off our theta. Theta is an element of, in other words, it's in there. Now, it also says assume u is positive. So we can assume, since the sine is positive, the y value is positive, so we're just going to go ahead and draw it into the first quadrant, right? Since the only options are 1 and 4, it's got to be in 1, where the y value is positive. So we go ahead and draw theta into quadrant 1, and this is u over 1, and this is opposite over hypotenuse, opposite u, hypotenuse 1. Let's go ahead and solve for that side. I'll call it side b. So u squared plus b squared equals 1 squared. I'm solving for b, so subtract u squared on both sides. So I got 1 minus u squared, and I square root. So b is the square root of 1 minus u squared. Let's put that in right here. Square root of 1 minus u squared. Now we're all set up, so we can finish this. So 3 cosine the arc sine of u. Remember, we called that theta, so we're just finding the adjacent over hypotenuse side on this. The adjacent side is that square root of 1 minus u squared. The hypotenuse is the 1. So the cosine of the arc sine of u is just the square root of 1 minus u squared. I don't need to put that over 1, right? All right, one more here. Let's do it with arctangent of 4u now. So number 1, let's take that inside. Arctangent 4u set equal theta. So we know the tangent of theta is 4u. Remember, theta, when we cut off the tangent, that was between pi halves and negative pi halves. But we're assuming u is positive, so we know this is into quadrant 1. Sine over cosine is positive. So x and y have got to both be positive. So we can go ahead and draw this into quadrant 1 as well. Now this is 4u over 1. So here's my opposite. There's my adjacent. Opposite, adjacent. 4u over 1. Go ahead and let's solve for the remaining side. The c. So we have 1 squared plus 4u squared equals c squared. Square root both sides. So c ends up being 1 squared is 1. 4 squared u squared 16u squared. Or I'll write that as 16u squared plus 1. That's our c. And finally, step 3. So the secant, we called the arctangent for u, we called that theta. Now remember, secant's the reciprocal of the cosine. Cosine's adjacent over hypotenuse, so this will be hypotenuse over adjacent. Hypotenuse over adjacent. So the secant of theta, which is the arctangent of 4u, is square root of 16u squared plus 1, all over 1. And hopefully that'll kind of get you going on the assignment today. Thanks so much for taking notes. See you next time.